Today, we're focused on advanced security and particularly identity. I always start by sharing this question, and it would be great if you could drop what you think the answer is in the chat. But I want to ask everyone listening this morning and afternoon, how many U.S. healthcare institutions do you think were successfully hit by ransomware in 2024? Any ballpark guesses? You can share a number in the chat or come off mute. 1,200, Michael, okay. All, Howard, yeah. Right? Yeah, 490%. Okay, 90% of all healthcare institutions. Good guesses. Anyone else want to take a crack at it? So it looks like we're all over the board. Well, the 60%, okay, the right answer is 389, not quite 1.5 million. Thank God, Patrick, but 389. The key word in that question was how many US healthcare institutions were successfully hit by ransomware. So 389 were hit. And the reason I asked this question is because when Marie and I have these conversations with customers and partners, a lot of the times there's an assumption that what we do in the cyberspace stays there, that our attackers have no kinetic, real world, physical impact on the people that we protect. And this number right here, 389, proves that wrong. Why? Because each time you see a healthcare institution hacked, that might have been a critical surgery delayed, a network closure. Maybe a hospital had to switch to pen and paper for an entire week. Could have been appointments rescheduled, ambulances diverted of a loved one, and more. And so these kind of attacks are happening, and they're having real world impacts on those we hold most close and dear to us. And on top of that, state-sponsored hackers are no longer just, if you could please just mute yourself, I would greatly appreciate that. Thank you. So on top of that, state-sponsored hackers are no longer just stealing your IP in what is considered, the mass commercial IP theft era of 5 or 10 years ago. But they're also working with cyber criminals. They're setting up backdoors for future conflicts. They're running an influence campaign and more. And if you don't believe me that attacks are getting more targeted and more complex and sophisticated, I want you to look over this chart. This is actually a breach of us. This is a breach of Microsoft. This is the PRC and Storm 0558 breach that happened just a summer or two ago. So it started with the PRC backed threat actor group, or the People's Republic of China, somehow gaining access to a Microsoft engineer's credentials. Now, we still don't know the full details of how they were able to do so, but they got access to an engineer's creds. And this is a friendly reminder that identity is the linchpin. Then one of our servers crashed, and an MSA signing key, which is essentially our crown jewel, was included in the log of the crash. And in this chart, you'll see that referred to as a crash dump. So they got access to creds, a server crashed, it logged that crash, and within that, it had our signing key. That crash automatically went to an automated debugging environment, but the automated debugging environment failed to detect the signing key. And the PRC presumably gained access, leveraging the stolen creds to that MSA signing key. So they were sifting through crash dumps for we're not sure how long. But they leveraged their stolen creds and they started to authenticate themselves and started to forge auth tokens. And where did they go? They went straight to Pennsylvania Avenue and they went straight to the White House. And that is an example of companies at risk. There are also risks to individuals, though. And a lot of people might say, this is everything you might need personally, whether myself or Marie or the listeners on this call to be secure. You might need Windows Hello or Face ID, as you see there under the first authentication blade. Maybe it's Proton for email, or Molvad or a VPN that your company demands, or FileVault for security. And maybe it's text or Signal for text, which we know has certainly gotten a lot of attention in the news as of recent. So there are risks to companies, there are risks to individuals, and then there are also risks to institutions. So we almost lost the CVE disclosure system. This was about 2 or 3 weeks back, if you remember seeing it in the news. And if you're wondering why that's so important, well, if you're a vulnerability, and we're walking through a story now of I'm just a vulnerability, how do I become a finding or a patch? Well, it starts with that vulnerability, as you see at the very top of this chart here, being discovered and disclosed. In MITRE, which is funded by the Department of Homeland Security, and CISA, published as the CVE. And this part almost went away. And then NVD, which is funded by NIST and others, might add a CWE or a common weakness enumeration or configuration and mitigation instructions for that vulnerability and more. And then this, in the long term, feeds into security tooling, whether that's tools like Wiz or Palo Alto and other, and that helps lead to patches. But without MITRE's CVE program you see there in the middle, this would no longer exist. So the threat landscape isn't great. We have, like I said, risks to companies that are highly targeted, sophisticated, and complex. There are risks to individuals, and you might need all of this just to stay protected for your own digital hygiene. And then we also have risks to institutions. What's the common theme? Well, identities and relationships are the absolute linchpin of every attack, but they're also one of our most powerful tools to disrupt them. You might have heard this phrase before: attackers don't break in, they log in. I do want to take a quick note that we are noticing an alarming trend, and that trend is that attackers are bypassing EDRs entirely. EDRs are incredibly well managed. If you have ever been to RSA, I went for my first time last year, and you walk the floor, I mean, you're just blown away by the sheer number of EDRs that are out there. And what we're seeing today is that EDRs are the most well monitored and logged part of this security stack. If you are coming off mute too, you could just mute yourself. That would be great. Or Adrian, if you could do so, or Marie for me. So attackers are bypassing EDRs entirely. Another reason why, well, SIEMs are inherently expensive. Tools like Sentinel, or maybe use another one, can be expensive. Logs are expensive to ingest, and not only to ingest, but also to retain for long-term retention. And the detections are also lacking. Some customers might not even have an identity detection and response solution deployed. So before we talk concepts, I just want to cover some security anti-patterns as well, from what Marie and I and others have heard from partners and customers. What's the difference between EDRs and XDRs? I'm going to answer this right away. That's a great question, Dave. EDRs, endpoint detection and response, that is protection for your devices. XDR essentially incorporates more than just endpoints, more than just devices. It might cover your email, it might cover the cloud apps you have in your organization, and more. So XDR expands the telemetry and the reach of an EDR. It's just in evolution of an EDR solution. So what are some common anti-patterns that we see? Well, partners and customers still often overlook the basics, right? That means no phishing-resistant MFA deployed. Maybe they don't have an identity detection and response solution. They have no automated patching and more. And a way we see this fix, and the best practice, is to automate as much basic security hygiene as possible and to focus on the basics. Hence, the Back to the Basics series. Anyways, but automate hygiene. Automate your patches, automate your backups, deploy attack surface reduction rules, and adopt Windows Hello or FIDO2 and more for that phishing-resistant MFA. A lot of teams also deploy without alignment. They might just try to force adoption of a new shiny product without ownership or without buy-in and without clear established use cases too. So instead, align on deployments, right, with teams and into your grand strategy, and use cloud-native controls. That could include RBAC. That could include policy enforcements when possible as well. Please don't waste time on legacy resources. I think that stands for itself. Retire or contain legacy systems that are barely still supported. The fourth point you see on the left-hand side is artisan security. This is, custom-built tooling, or the idea that you need custom-built tooling or a manual process for everything. And this might seem efficient in the short term, but it really can't scale that well. So what we recommend doing is start an experiment with off-the-shelf solutions and make sure to correlate signals across your identities, your endpoints, as well as the network to reduce your mean time to detect and respond, your MTTD and MTTR. There's disconnected execution. This is when teams only focus on short-term fixes with not a lot of long-term strategy. The goal is really to prioritize intentionally. I can't emphasize this enough. So balance your more urgent security needs with a longer-term, test and iterate sort of mindset. And then lastly, justify investment. We need to normalize the fact that security is a team sport. It's shared, across IT, engineering, marketing, sales, and others. And we need to hold each other accountable, and be able to justify the sometimes expensive investments that we make. So let's talk advanced identity concepts and controls. We're going to cover some of the basics. This slide, I just want to go over the distinction and difference between authentication and authorization. This is a friendly reminder that authentication grants access and authorization determines your level of access or your level of permissions. There are many different authentication methods within Entra itself, and I want to overview and go over the good, better, and best of authentication in Entra. Bad authentication is if you solely rely on passwords alone. Good, as you see on the chart on the right, includes pairing a password, maybe with phone-based authentication like SMS and voice, although this is starting to become legacy. It's good to pair passwords with the authenticator app or software and hardware tokens as well. This is better in our good, better, best scenario. Software OAuth tokens are typically apps. So Entra ID generates the secret key that's input into the app. And then there's hardware tokens. These are actually small hardware devices. They look like a key fob. They display a code and they refresh about every 30 to 60 seconds or so. And then as you see on the right-hand side of this chart, best, which is the ideal state, is passwordless authentication. That might be Windows Hello for Business, FIDO keys, and more. For identities and identity types, you can assign identities to people. That could be the guest in your environment. If you're an MSSP, your other partners, partner-to-partner work, customers, and more. You can assign identities to physical devices as well, such as phones, computers, and IoT devices. Although I personally wouldn't recommend assigning an identity to an IoT device or a device sitting on your network. They're just, they can be difficult and complex to secure as well. And you can use groups to give permissions to all members of the group instead of having to assign access to rights individually. And it's common to create a security group for a specific policy. An example of that might be self-service password reset or conditional access requiring MFA. And lastly, as another friendly reminder, you can assign identities to software-based objects, such as apps, VMs, and services and containers. And these are referred to as workload identities. And I'm going to cover two key concepts within workload identities you see highlighted here. Service principals are essentially an identity for an app that delegates its identity access or IAM functions to Entra ID. And for service principals to be able to access resources secured by Entra ID, app devs must manage and protect these creds. So if not done correctly, this can introduce some vulnerabilities for your environment. And managed identities help offload that responsibility. They're a type of service principal that are automatically managed within Entra. So at their simplest form, and we're going to cover conditional access, they are if-then statements. So assignments determine which signals to use, and there's sign-in risk and user risk. I won't spend too much time on this slide, but I want to make a distinction between these two. Sign-in risk flags suspicious activity and indicators at the sign-in, right? So maybe that's impossible travel, or maybe you're in an unfamiliar location. Whereas user risk considers broader indicators. So we're analyzing the user profile, whether you are using leak creds, whether you're encoding commands or you're dumping memory and more. And access controls determine how a policy is enforced. So if-then statements, if you don't meet a condition, we could block access. If you do, we'll grant you access. And let's say you only meet some of the indicators, well, we can provide you a limited experience. Just a couple more slides. PIM is another critical concept. And I just want to focus on this first line here, which is just-in-time access. You might have heard of its brother or sister, however you would phrase it, as just enough access as well. But just-in-time provides privileged access only when you need it and not any time before. And just enough provides you, just enough access you need to do your job. So it's time-bound. It includes a start and an end time. It's approval-based. It's monitored. And it's audible. So where should you start if you're a partner or a customer? I highly recommend starting with basic security hygiene to better protect yourself and your customer. So start with enabling passwordless MFA. Remember, that is the ideal state for authentication, like Windows Hello or FIDO keys. Next, apply zero trust principles, including least privilege access policies. Use an XDR. That was a great question earlier from Dave. What's the difference between an EDR or in an XDR? XDR is just bringing in more telemetry from perhaps identities, from cloud apps, and more. Ensure everything is up to date. Automate patching and automate updates, and implement the right protections for your data, like DLP policies. And before I hand it off to Marie for some of the demo, I want to cover some advanced controls. If you're an MSSP listening in on this call and you've already done the information I just shared, kudos to you. But let's cover what we think is an ideal state for advanced identity security. So credential theft is still the #1 initial access vector. Remember, attackers don't break in, they log in. So even with strong passwords or legacy MFA, like SMS is starting to slowly become legacy MFA, phishing attacks still work. So enforce FIDO2, Windows Hello for Business, again, or CERT-based MFA for all admins. I can't emphasize the second point enough. Implement PowerShell restrictions and limit it for only admin use. Use LAPS as well, local admin password solution. This is essentially a solution to avoid shared local admin password. It essentially mandates a password per machine and unique local admin creds. And access is controlled by AD as well. So attacks like NotPetya, that was a major Russian attack against Ukraine prior to Russia's invasion in that war, thrive off gaps left by poor security practices like not implementing LAPS. Use LDAP signing in LDAP's channel binding so attackers can intercept your creds. So LDAP stands for Lightweight Directory Access Protocols. It's a protocol or set of rules essentially that's used to manage access and communicate with directory services. So think of LDAP as the way computers and apps talk to AD. So this is also an important point because within AD, this is where most information is stored about your users, your groups, your passwords, and more. So LDAP by itself is unencrypted, but by using LDAP signing, this ensures no tampering. And LDAPs, which is essentially just LDAP over SSL or TLS, in binding, we can also prevent attackers from sniffing those creds out. Require admin consent for apps accessing organizational data to prevent attackers from using malicious OAuth apps and abusing them. And lastly, block email forwarding, automatic email forwarding, and closely monitoring forwarding to external domains. And this helps prevent attacks like business email compromise. All right, Marie is going to walk us through a quick demo on how to create those conditional access policies.
Thanks, Zach. I'm going to go ahead and share my screen. So we're going to have a quick look at how to create an Entra ID conditional access policy. And for that, I logged myself into the Microsoft Entra Admin Center. And note that for being able to do that, you need to have conditional access administrator as a role as a minimum. We're going to go into the protection blade and then go down to conditional access and then policies. And then I'm going to go ahead and click the new policy button here. The first thing it's going to ask you is to add a name. So today I'm going to be showing how to require a certain MFA strength for all my users. But in an enterprise context, we do recommend that you follow some sort of standardized naming convention for your policies. Then I'm going to go down to assignments. And as the policy suggests, the final goal is that it applies to all users. But a best practice when setting up a conditional access policy is to actually select a subsection of users. So that's exactly what I'm going to do. I'm going to get started and just assign it to my sysadmins to test out the policy. And then I'm going to go down to access controls and I'm going to hit the controls here under grant. And then I'm going to select to require certain authentication strength. As you can see, I can either block access or grant access if a certain thing is valid. In this case, I want to grant access when we have phishing resistant MFA. Before hitting select here at the bottom, if I would select multiple controls, it's good to see that I can either require that all selected controls are valid for that policy to kick in or only one of the selected controls. In this case, since I'm selecting only one, it doesn't matter. So I'm just going to go ahead and click select. And then before creating that policy, you can see here at the bottom that I am enabling that in report only. And that is a suggested best practice when you get started with your conditional access policies. So the idea is that you deploy that policy, have a look at how it behaves. If you're happy with it, you can go ahead and enable it and then expand the scope later on for all users that should get targeted by that policy. That concludes the demo section. With different identity controls in place to verify who's accessing the environment, our next critical focus is what they're accessing, and that very often means APIs. So in recent years, we've seen a steep rise in the volume and severity of API-based attacks. And so this slide just highlights a few real-world breaches from the past year. And what we see here is sensitive data being exposed at a massive scale. There's tens or hundreds of millions of users affected across different industries. And what's important is that these aren't isolated events or fringe cases. They reflect a fundamental shift in how attackers are targeting modern architectures, and APIs have really become almost the connective tissue of digital services, and they power things such as mobile apps, but also microservice systems. And so they introduce new risks, and unfortunately, the consequences can be quite serious. So we see financial loss, compliance violations, and also obviously reputational damage. And it's no longer an edge case for security teams. So API security really has to be a core part of the overall strategy. And so in this portion of the section, we're going to step through the underlying reasons why APIs are so frequently attacked, and then how these attacks usually bypass traditional defenses, and then what patterns and principles can help reduce that risk, especially for teams that are building or operating modern cloud-native systems. So APIs, like I mentioned, are everywhere, whether you're booking a flight, using a weather app, checking out your grocery cart, they're all powering that interaction. And actually APIs now account for over 70% of all internet traffic, and that number keeps climbing. So this growth is being driven by shifts in obviously software architecture from monoliths to microservices, and from single systems to distributed and more cloud native services. And so obviously this improves agility, but it also complicates the work for security teams. And that's because there's no longer a single point of control, and traditional models like network firewalls or web application firewalls are not really designed to understand how APIs behave. So many teams still rely on standard tooling, like app gateways, WAFs, API gateways to provide API security. And those are necessary, but they're unfortunately not sufficient because they operate at the perimeter and they use rule-based logic, and they have limited visibility into API semantics and behavior. That's because the real risk with APIs really lies in business logic abuse. So attackers will authenticate as normal users, but misuse the API by, as an example, chaining calls, escalating privileges, or extracting large amounts of data. And the worst part in that is that these behaviors look like normal traffic, which means that they completely get missed by traditional controls. And so even if you have cloud level protections that are enabled, you might still get excessive data exposure. And so that's why API-based attacks don't only succeed, but they also scale very quickly. And that's something that threat actors understand. And that's why APIs have become one of the primary attack vectors. So in the next few slides, we're going to explore how to reduce that attack surface, and we'll have a look at a few different scenarios. So now that we've seen how APIs are being targeted and why traditional defenses often fall short, let's walk through a slightly more realistic view of how attackers navigate your environment and how we can reduce that risk by prioritizing the most vulnerable APIs. So starting on the far left, an attacker initiates an interaction through an internet-facing API. And these APIs might be exposed by design, like for something like a mobile app or some sort of external integration, but they're often misconfigured. They maybe lack proper authentication. They return overly broad data. And so these APIs are routed through infrastructure, like maybe Azure API management, some load balancers, network interfaces. And from there, attackers can begin to pivot deeper into your environment. So in this example, a misconfigured API connects to backend services like a VM, secret store, and then a storage account that contains sensitive data. And so these systems might also have excessive permissions or insufficient isolation, and they really give the attacker a clear path to escalate. And then things become even more critical when APIs connect to things like AI workloads, because a compromised GenAI endpoint that might have access to secrets or identity tokens can be used to retrieve sensitive data or access cloud-native AI services and even data sets. So what's the key takeaway from this slide? It's that the attack surface isn't just the API itself. It's everything that the API connects to. And so without contextual visibility into identities, permissions, data flows behind those APIs, we can't really meaningfully prioritize risk. And that's why we need to shift from a perimeter mindset to an attacker-informed model. So which APIs touch critical data, and what's the downstream blast radius, particularly like across compute, storage, and AI services. So ultimately, it's more than just about hardening endpoints. It's about mapping your APIs to your business logic and the different data exposure paths that you have. And that's definitely like the foundation on making smart prioritized decisions in an API-first architecture. Let's now take a look at how a typical API breach unfolds and what an effective security posture should do to prevent it. So in this scenario is rooted in patterns that we've seen across real-world incidents, including some of the high-profile breaches that we reviewed earlier. And it begins with a common and often overlooked phase, which is reconnaissance. So threat actors don't always start with sophisticated exploits. They actually start by probing publicly accessible APIs and look for misconfigurations. So in this case, the attacker finds an API that's exposed to the internet and it doesn't require authentication. And it returns metadata and oversensitive user data in its default response. And that's a textbook example of several OWASP API top 10 issues. You can see that on the slide as well. It's broken authentication, excessive data exposure, security misconfiguration. And what's really important there is that there's no exploitation of the vulnerability in the code itself. It's really an exploit of the design and configuration. And that's what makes API breaches so effective, is that the attacker is actually using the API exactly as it was built, but outside of the intended context. And so once discovered, these APIs are often called repeatedly or at scale to exfiltrate user data. And that's a pattern that we've seen across many past incidents. And so the attacker doesn't just need advanced malware, they can just use automation and persistence to achieve their goals. And let's now have a look at how a mature security posture looks like in this case. So it starts with posture management. And that's things like classifying APIs as externally exposed, identifying those that return sensitive data, recommend control hardening, like enforcing authentication. But posture is really just the baseline here. So you want also to have some sort of real-time behavior detection. So if there's a sudden spike in payload sizes, if there's a non-human identity pulling data repeatedly across a bunch of different user IDs. And these are all signals that when correlated with the posture insights, will really enable organizations to catch abuse as it happens and to take proactive steps before data gets lost. Another API exposure scenario is this one through the lens of data governance. So again, starting at the top left, a threat actor begins probing a target application and they look for exposed endpoints. They find an API that is something like echo resource and then like a certain employee ID, which is seemingly harmless service that's used by a travel desk partner to look up employee info for booking workflows. But when the attacker calls this endpoint, the API responds with more than it should. So it includes things like sensitive employee records, basically. And so in some cases, even personal data or maybe identifiers. And moving across the top, we see that the attacker recognizes that the endpoint lacks proper access control. And that's a classic case of broken object level authorization, or BOLA for short, which is one of the most common and impactful API risks. The attacker then obviously uses that weak point to laterally move across the environment, escalate access, and discover other sensitive endpoints and extract personal or confidential data. And that's where data classification and API security have to work together. The organization in this case has managed APIs, but to properly assess risk, they need visibility into what data those APIs expose. So that's where you have tools like Microsoft Purview and Defender for Cloud that align. So they will do things like assess API endpoints for data exposure. They will monitor for anomalies in API behavior that may signal abuse or exploitation. And the outcome is API security that's aware of the data itself and not just endpoint exposure or traffic patterns. And so that alignment ensures that sensitive data isn't just protected at rest or in storage, but as it moves through APIs. And then let's look at a last scenario, which is broken authorization. And that's a very common scenario as well, through parameter manipulation. So again, starting from the top left, a threat actor begins not by breaching the system, but by signing up, creating a legitimate authenticated user account. And this gives them a clean and authorized channel into the application. And then they analyze how the application handles API calls. particularly those that are predictable patterns like user ID, and then there's a certain ID. You can see here 12, 13, 14 on the slide, and then account details. And they notice that the system doesn't properly enforce object level access control. So in other words, their application doesn't verify that the user is only accessing their data. And that's, again, an example of BOLA that's identified in both OWASP and MITRE attack frameworks. And so now the attacker can basically just begin enumerating by calling the same endpoint repeatedly, but incrementing the user ID. So they do user ID 12, and then 13, and then 14, and the application keeps returning data and never validates ownership. And so by the time that pattern is detected, if at all, the attacker may have pulled a bunch of sensitive data for hundreds or even thousands of users. Looking at the defense path in green here, that's where runtime behavioral detection really becomes essential. So obviously, like I mentioned, we have static tools and gateways that unfortunately often miss this type of activity because each request is technically valid, but behavioral analytics will tell a different story. And so again, something like Defender for Cloud can detect this enumeration based on traffic patterns. For example, if a single user rapidly requests a sequence of resource IDs, which will raise a security alert, flagging the suspected abuse, and then give responders a chance to intervene before the damage is done. But yeah, ultimately, broken authorization flaws don't always show up in static scans or policy checks. They do show up in behavior. And so catching those early requires obviously telemetry, but then also continuous monitoring, and most importantly, context within the environment. To wrap up the API security portion of this presentation, I'm going to cover a set of different advanced controls. So the idea is that no matter what framework, cloud, or platform you're building on, these controls are interesting and important. The idea is for the first one to continuously discover and inventory all APIs, which will include shadow and deprecated endpoints. So each unknown or unmanaged API, unfortunately, represents a potential attack path. And so enterprises obviously often operate hundreds of APIs, many of which might be documented, undocumented, or outdated. And so to reduce the surface attack, organizations should continuously scan their cloud and application environments to detect all APIs in use, and then assign proper ownership, classify function, and then decommission any unused ones. And to prioritize this inventory enables more targeted security controls and also eliminates hidden exposures. Secondly, we want to establish an API governance framework across the full API lifecycle. Effective security starts with structure, and having good governance practices means that you embed controls from the initial design all the way through versioning, testing, change management, and then also ultimately retirement of an API. And so APIs should really be treated as products, tracked in catalogs, owned by accountable teams, and subject to review before rollout. And having proper governance in place will also help enforce consistency in input validation, authentication requirements, deprecation handling, and it will reduce the chance of different shadow APIs or unauthorized reuse of maybe something like an outdated endpoint. And then thirdly, you want to apply zero trust principles to every API. So basically, you want to treat every API call as if it was coming from like the World Wide Web, like open internet, right? Like you want to enforce strong authentication, short-lived scoped authorization tokens like OAuth or OIDC, and you want to ensure that only authorized services and users can interact with those sensitive endpoints. And then the fourth point is that you want to implement adaptive rate limiting and abuse detection mechanisms. So there obviously APIs are highly susceptible to automated abuse. So you want to include like brute force attack detection, credential stuffing, logic abuse, like those types of things. And some effective defenses for that include dynamic rate limiting per client or identity, also challenge mechanisms such as maybe like a CAPTCHA or behavioral verification. And then obviously we have machine learning based anomaly detection that can help flag traffic that might deviate from normal usage. And then finally, we want to integrate data loss prevention, or DLP for short, controls into the API layer. And that means that API traffic should be inspected for sensitive data types such as PII or financial information, credentials, both for inbound and outbound. And so DLP policies can trigger things like masking or encryption or blocking if certain sensitive fields are present and the caller lacks proper authorization. And that helps ensure that APIs don't inadvertently expose confidential data, and will also help an organization like support an organization's compliance with regulatory standards like GDPR, HIPAA, or PCI DSS. So as we've seen, APIs represent one of the most exposed and commonly exploited layers in modern cloud applications. And the interesting thing, obviously, is APIs don't exist in isolation, right? In fact, most of the APIs we've discussed so far, whether they're powering things like microservices, mobile apps, AI workflows, are often hosted and orchestrated inside containers. And so with the shift towards containerized workloads and Kubernetes-based deployments, the attack surface is shifting again, and this time deeper into the infrastructure stack. So let's now have a look and pivot away from interface level risks to the underlying runtime environment and talk a little bit about how to secure containers too. So as you know, containers offer incredible scalability and also agility, but they also introduce a plethora of new risks that go unnoticed until they're exploited. What you see here are the 5 most common points of failure across the entire container lifecycle. And these are the exact areas where attackers are probing. So starting from the left, we have code, where supply chain attacks often begin. So that includes malicious code or backdoors that are introduced through dependencies or container images that are pulled from untrusted sources. And then in the build phase, CI/CD pipelines can be poisoned, so attackers might embed malware into automated workflows, hijacking the very systems that they're meant to speed up delivery. As we move to ship, we see that threat actors may tamper with artifacts, they may swap or modify images in public or private registries. And so without proper image signing, as an example, or verification, it's easy to unknowingly deploy a compromised workload. And then we hit deployment, and there are misconfigured permissions, open ports, excessive privileges are all common mistakes that create serious exposure once workloads go live. And then finally, we have runtime, and that's where attackers take advantage of vulnerable or misconfigured containers to break out or escalate privileges and move laterally inside your environment. And here's the thing. Attackers only need one weak link to succeed. And as defenders, we need to secure across the entire pipeline. So let's walk through what this actually looks like in practice. I'm going to show a real-world attack path where an exposed container becomes the entry point to a multi-cloud data breach. So this slide illustrates an example of how a container compromise can quickly escalate into a full-blown cloud breach. It crosses boundaries between services, identities, and even cloud providers. And so starting from the left, we have a Kubernetes service, in this case, an EKS cluster, that routes internet traffic to an exposed pod. And that pod is running a container image that's pulled from a public registry, but that image contains known vulnerabilities, unfortunately. And so the attacker scans the public IP space, finds the exposed pod, and exploits the vulnerability to gain access. And that gives them a foothold, not just into the container, but into the broader cluster. And from there, the attacker moves laterally. So they find that the container uses the host network, which increases risk. They extract credentials or tokens that allow them to authenticate as a managed identity. And then that identity has permissions, perhaps even overprivileged, to access a critical asset, which in this case is a database hosted in AWS or Amazon RDS. And so at that point, the attacker has exfiltrated sensitive data, and it's all stemming from a vulnerable image and a misconfigured container. And that's what is meant when we talk about from breach to spread. So it's not enough to secure a container in isolation. You need visibility across the entire chain, from the image origin to the CI/CD pipeline to the cluster runtime, and then identity and data surrounding that. And so on the next slide, we'll just have a quick look at how Defender for Cloud tries to approach that. So basically, the capabilities shown here fall into 2 categories. So we have Defender Cloud Security Posture Management, or CSPM for short, which focuses on agentless discovery and security posture. And then we have Defender for Containers, which adds runtime protection and also deeper workload telemetry using sensors. So looking at Defender CSPM first, that layer provides agentless insights into Kubernetes clusters and also container registries, and it helps to identify what is deployed, where it's running, and whether there's any known vulnerabilities or misconfigurations. And then there's also things like container image scanning that happens directly in CI/CD pipelines that allows organizations to block untrusted builds before they even deploy. And there's also things like attack path analysis that connects exposed or vulnerable workloads to high-value targets like identities or data stores, and helps to remediate that based on actual risk that is being detected. And then on the other side, you have Defender for Containers. And there, like I mentioned, you have optional runtime sensors that provide even deeper protection. And so that runtime monitoring can detect behavioral anomalies, suspicious activity like drift, and also unexpected changes, even at the OS level, such as containers that are spawning, unexpected processes, or maybe accessing unusual system paths. And it also includes something like detection and response capabilities to, as an example, correlate low-level signals across your workloads and infrastructure. Closing off the container security portion of this presentation, I'll just go over a few advanced controls. So the first one is that you want to require every container image to be cryptographically signed and accompanied by a verifiable SBOM before deployment. And that really helps mitigate risks associated with image tampering or supply chain compromise. Secondly, you want to run CI/CD jobs in isolated, non-privileged environments. And that's because build infrastructure is very frequently attacked by or targeted by attackers due to its privileged access. So CI/CD jobs should run in ephemeral, isolated environments that and never on something like a shared or persistent infrastructure. And then thirdly, we want to enforce least privilege by disabling root, dropping Linux capabilities, and applying pod security policies. That's again because many containerized workloads run with excessive permissions. And so that unfortunately increases the blast radius of a compromise. And so to reduce that risk, you can enforce things like run as non-root or disable unnecessary Linux capabilities. There's also Kubernetes RBAC that should be applied strictly to ensure that pods and services operate only within the privileges that they require. And so the goal is really to prevent escalation, even in the event that a container gets exploited. And then fourth point is to use network policies and mutual TLS to microsegment workloads and isolate your dev, test, and prod environments. They should exist in separate networks with strict boundaries. And when you have policies that are correctly enforced, even a compromised container, again, cannot freely scan or move laterally within the cluster. And then finally, you want to encrypt all secrets and sensitive data at rest and in transit, and then rotate credentials via a central vault. And you want to do like that rotation regularly to reduce the exposure window. And together, these types of measures again, ensure that even if a container is compromised, like zero trust, that at least the sensitive data remains protected. And so we've now covered how to secure APIs and containerize workloads in the cloud. And as organizations embrace AI, there's a whole new layer of risk that's emerging. And that's because that's where models, data, and user inputs really converge. And so to take us into the world of AI security from a cloud native perspective, I'll hand it back over to Zach.
All right, everyone who's still there, just hang on with me for another 10 minutes. We're going to get through about 5 more slides and go into a very interesting demo. So thank you, Marie, for covering APIs and containers. We're asked this all the time. What's AI's impact on threats today? 2 important things to note. There's 2 types of AI security. There is AI for security. That is Security Copilot. That is Google's new Sec Gemini. That is Cisco's new Foundation Sec 8B, their open source security tool. That is AI for security, like incident response. And then there is a security for AI, like Purview, and that's where you might see controls like data loss prevention and labeling and classification come into play. If you're wondering how attackers might use ChatGPT, here's my favorite story of malware research from VX Underground, the largest online malware repo. They said, we decided to finally evaluate how ChatGPT works within our workflows for malware development. They've been a big fan of using Windows Component Object Model. I had not heard of Windows Component Object Model, and I work at Microsoft, so this story resonated with me. And they said they're a big fan of using it for malware research, but COM is wildly undocumented and poorly misunderstood, and it's just kind of an old relic. Well, to make a longer story shorter, they used ChatGPT as a search engine on steroids, asking it about Windows COM objects and whether they could perform malware-related tasks without probably explicitly saying that. And they did some further investigation, and it even provided proof of concepts in code demonstrations. And I want to bring your attention to this last highlighted point. They said some of the material did not even exist on Stack Overflow or places you would traditionally find code examples related to the material. So it essentially it's a search engine on steroids, even for the most obscure components of Windows that could be used for malware development. And it's pulling all of this information from old blogs or random forums that you otherwise probably would have taken hours to find. On this slide, I just want to emphasize that there are traditional attack vectors like identities, your devices, stuff that sits on your network, even your data, particularly for AI. But GenAI also introduces new attack surfaces. This could include your prompts that your users ask a model, the model's responses, custom plugin development if you're a partner. And there are also serious concerns about jailbreaks, training data poisoning, model theft, and more. That's also not to disregard, though, SQL injections, remote code execution, data exfiltration, and some of the more iconic hallmarks we see today. So how do we secure Gen AI apps if our org is using them? I'm about to demo this, but with Defender for Cloud Apps, you can get visibility into every single Gen AI app that's in use by your org. We offer risk assessments that evaluate over 90 risk factors across security, legal, and compliance frameworks and controls. And each Gen AI app in use by your org or that we support, there's some 30,000, are assigned a risk score 0 to 10. And that helps you determine what Gen AI apps are sanctioned or which are allowed and good for use and which are not. So Defender for Cloud also works with built-in content filtering from Azure AI Content Safety to create alerts. I'll walk you through an example. So here, a user inputs a malicious prompt into a Gen AI app using Azure OpenAI service. Because the app was built with Azure AI Content Safety enabled, the jailbreak attacks were detected, and the responses were actually blocked. And Defender for Cloud will ingest that detection from Azure AI Content Safety. It compares it with some threat intelligence, and it confirms that it is malicious behavior. And it starts spinning up alerts. And those alerts can be correlated. If you work in a SIEM, you're probably aware of this, but they can be correlated into incidents. And you can investigate them either in Defender XDR or in Sentinel. I'm going to quickly cover some advanced controls for AI security. Use a key vault to store your API keys. Marie just covered some of the importance of why this is so critical. Avoid hard-coded secrets. If you're working on custom plugin development, please don't put your secrets in some open source GitHub repo out there. And I actually don't have this on this slide, but if you are an enterprise, use GitHub Advanced Security. It'll catch those secrets for you and rotate your keys regularly. Disable dormant apps and remove inactive tenants entirely. A big part of the Secure Future initiative here at Microsoft was us removing inactive tenants that can be abused. Use tools like Defender for Cloud Apps. I'm about to demo how you can do so. Track completions, track your API calls, your orchestration, and feed logs into SIEMs. But don't just turn everything on. You want to make sure you optimize. Otherwise, tools like Sentinel might get really expensive. And if you want to learn how to optimize, come to our next session a week from right now. Leverage data loss prevention. Many tools like AI or many AI tools like Copilot inherit the sensitivity labels of the documents and emails that they're referencing. And apply policies for user and sign-in risk. A friendly reminder, thank you, Scott. Friendly reminder that user risk is profile behavior, heuristics, and sign-in is where you are at the moment you're attempting to sign in, like impossible travel. Apply policies for device compliance. You might have seen this on your iPhone. There's a new iOS update even out there, I think, this week. And use policies for trusted IPs. Okay, let me get this demo up. So as an analyst, I primarily use Defender XDR as my extended detection and response solution to monitor my GenAI apps. And I'll navigate here on the left-hand side to Cloud Apps and Cloud Discovery. So I want to make a distinction that Cloud Discovery, which you see here, this first blade, covers the actual cloud apps that are used in your environment by using network and monitoring your network traffic. Whereas the Cloud App Catalog provides risk and compliance profiles for some 30 or 35,000 apps that we support. So Cloud Discovery is more for the actual Gen AI apps that are in use by your org, and the Cloud Apps Catalog is everything that's supported, and this is primarily for governance. Immediately, you'll notice your apps, your IPs, users, devices, and even your network traffic here on the right. but I want to filter this down just a tad bit more. So I'll go to app categories and we'll toggle over, I think it's 3 to generative AI. So let's select generative AI. And here's where you can find all the Gen AI apps that are in use by your org. There's only one sanctioned, which is another term for allowed Gen AI app in use in this demo environment. To no surprise, it's M365 Copilot. We see that it has a risk score of 10, which is actually a good thing. That means it's very secure. And if you're wondering how that risk score was determined, you just select the app and click on it, and it will open this page or this dropdown. So the score is broken down into 4 different categories, starting with general. That includes basic company information. Maybe it is the domain of the company, whether they have a disaster recovery plan, even the date that they were founded. Microsoft was founded in 75. The next category is security. This includes factors like, is there MFA required? Are there IP address restrictions? Then compliance, including notable compliance frameworks, such as what you see here on the right, SOC 2. And lastly, legal frameworks, including GDPR, as you see here. And if you disagree with this 10 out of 10 risk score for M365 Copilot or any other Gen AI app that's in use by your environment, you can change the weights of scoring. If we hit configure score metric, we'll open a new page. And here you can change those weights. If we don't care about the date Microsoft was founded, which is common, we'll set this importance to ignored or 0 in the risk score factorization. If we care a lot about MFA, which we should, or data at rest encryption, we'll set that priority to very high, and it will carry more weight in the scoring. That is how you can adjust the score metric for your Gen AI apps. And if you were to open the information about the app itself, you'll find data on users, traffic, IPs, and devices associated with that Gen AI app as well. Let's go to the Cloud App Catalog and open this up. Immediately, we'll notice that there are 35,000 generative cloud apps supported in our environment, but we want to filter this down. So I'll filter by category. This might take a moment. There we go. Category, generative AI, apply. And we'll filter by risk score. Anything lower than 7 tends to get a bit dicey. So we'll hit risk score 0 to 7. And now you can analyze Gen AI apps like, for example, Otter AI Note Taker, you see here, that have a score that's lower than 7. So as an analyst, I can review, if I'm using Otter AI, their security controls, what they have implemented and what they don't, the compliance frameworks they support. They are approved for SOC 2, but not a lot of the ISO frameworks. And we can also see their supported legal frameworks. They are, or they do support GDPR, which is good. And you can do this for every Gen AI app that's out there. And if you disagree with the score itself, if you think Otter AI Note Taker is a 10 out of 10, you can actually request a score update, and you can tell us why you think this app needs to be reassessed as well, and provide that detail here. Okay, I'm going to show one last thing. So if you build a custom model, you can monitor it in the Azure portal and in Defender for Cloud. So let's open Defender for Cloud and the Data and AI Security Blade on the left side here. This is where you can analyze high severity incidents related to your data and AI usage. You can see critical and high severity recommendations, your sensitive data, shared, and even AI-related resources in the bottom left here. If we analyze alerts, this is where you will be alerted on attacks like, for example, prompt injection, like what we see here, suspected prompt injection and smuggling detected. So this is where you can get alerted on malicious activity related to AI and take action there. And if we go back to Defender for Cloud and to the Cloud Security Explorer Blade, This is where you can create queries to monitor these alerts as well. We can go to select resource type, AI and ML. Let's say we want to get monitored on, let's see, AI platforms, Azure OpenAI. You can query for, let's say, high severity incidents related to Azure OpenAI. And so you can do this for a variety of different models that we support. And that's how you can protect and monitor not only your Gen AI apps by using the Cloud App Catalog and Cloud Discovery, but also how you can respond to alerts related to data and AI security in Microsoft Defender for Cloud. And that is the conclusion of the demo and our presentation today. If you have any questions, please feel free to come off mute or drop them in the chat.